Hey y'all, so we're going to keep moving along here with our notes, and today we're actually going to cover two different pages. The first one that we're going to talk about is prisms and their parts. So I've attached a template on campus for you guys to download, print off, and copy into your notebooks. That will be a little bit easier because a lot of the words will already be filled out with some lines and spacing, so you don't have to worry about fitting it all in. If you don't have a printer at home, feel free to copy down these two pictures here. There's this 3D figure and this 3D figure. But I'll go through each one of these definitions and give you some time so that way you can pause the video, copy them down, and then see what I'm talking about. So, prisms are three-dimensional figures with two congruent and parallel sides called bases. Now, that's the important thing to know about prisms, is that they're not all going to have the same shape throughout. Like a cube is the unique type of prism where every side is the exact same polygon. They're all made up of squares. But there's more than just a cube in terms of prisms. Now, faces for a prism is each polygon that makes up the sides. So, for example, like this is a face here, this top part triangle, this like front rectangle is a face. I'll highlight it in the back here, this rectangle in the back here, as well as this rectangle in the back. And then here, this one is also a face. So in total, there's 5 faces that we're looking at for this particular figure. Now, in terms of faces, there's 2 different specific names that we look at. One is called a lateral face. So you've got lateral faces, and what lateral faces do is you could think of them as being the sides of your prism. So in a prism, your lateral faces are actually always going to be rectangles. So here, this is one of my lateral faces here. This is one of my lateral faces here. This one going in front here, and then this one in the back. So think lateral surface or lateral faces, because if you stand your prisms upright, if it's on its side maybe, it would be the ones going up and down laterally. So your lateral faces here, let me even draw some arrows to what we're talking about there. So this is a lateral face here. This is a lateral face here. And then this face here is a lateral face. Now, the difference between a lateral face and a base, and this is important to really know, is that your base is either on the top or the bottom. Now, that doesn't mean that when you're looking at your picture that it's the one that's like on the ground and the one that's on the top, because your prism could be tilted on its side. So your bases actually have to be the same shape and size, and they're parallel to each other. So in terms of my bases here, my bases are actually these triangles that are at the top and the bottom. So this is a base here. And I'll highlight all of this in. So that top triangle is a base, and then this bottom triangle here is also a base. So it's important to know what's a base and what's a lateral face, because when we get into actually finding information about these figures, so like surface area and volume and all that, you have to be able to identify what your bases are. So like this is a base here, and this is a base down here. So they can be any type of polygon, and we actually name our prisms based on what the bases are. So for this specific prism here, as we're looking at it, the bases are triangles. So this is called a triangular prism. because the bases are triangles. And then remember, for a prism, your lateral faces are always going to be rectangles. So this shape here has 3 lateral faces, and it has 2 triangular bases. Now, a few more definitions based on that. So before we get into those other 3, let's look at this shape here. Now, I'm going to go ahead and identify my bases first. So like this is a base up here, and this is a base down here. Notice that they're both squares or rectangles. I don't know that they're squares, but they're rectangular shapes. So this is a rectangular prism. And then my lateral faces, I'll do that in the same color. Like this is a lateral face, this one here, this is a lateral face here, this side one here, and then this front one. So there's 4 lateral faces there that you could be looking at. But really, as long as you're able to identify which two faces are your bases, then the remaining would be what your lateral faces are. Now let's talk about some edges. So edges are the segment formed when 2 faces meet each other. So in essence, it's like it is the edge of your shape. So let me highlight these. So we've got edges. It's wherever your 2 polygons are going to intersect. So like this is an edge here because those 2 are intersecting. This is an edge up here, edge and edge. This is an edge going up and down. This is an edge going up and down. This one in the back, it's dashed to show you that it's like you're kind of looking through the image. Imagine this was made of glass, but it's dashed to show that it's kind of behind the actual face there. This one here, and then this one here, and then this one. So if we wanted to count our different edges that we had in this shape here, there's 4 on the bottom, 4 on the top, and then 4 going around the side. So there are 12 different edges to this rectangular prism. Now a vertex is the point where 3 or more edges are intersecting. In prisms, we can think of vertexes as just being the corners. So like here's a vertex here, here's a vertex here, this is a vertex, and this is a vertex. So that covers all the top, but then I've got vertex down here, 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 and here. So this is a vertex, 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 and so on and so forth. So it has to be where 3 or more edges are intersecting with each other. And then the final one is the height. Now, the height of our prism is always going to be the distance between your bases. So that's why I kind of covered, make sure you identify your bases first, because then you can figure out what your lateral faces are. But in terms of the distance between your bases is, this would be the height of my prism here. So it's from the top to the bottom here. So this is my height. If I go back to my previous triangular prism here, my height would be this distance here. So it's the distance between your bases, your top and your bottom. So that's just the identifying their different parts of prisms, as well as like being able to figure out, well, what's a lateral face, what's a base. One other thing I didn't point out is a lateral edge. So in terms of edges, you have just normal edges, but then your lateral edges. Your lateral edges are just the edges of your prism that are along your lateral faces here. So they're going up and down. You can kind of notice if you tilted this upright. So that's page 40, prisms and their parts. The next is 42, and you'll have to do some drawing on this specific page here. But we're going to talk about surface area. And with surface area comes two different definitions. One is lateral area, one is total area. So lateral area is the area of all of the lateral faces of your prism. Remember from the previous page, your lateral faces are the ones that are not your bases. So in a prism, they're always the rectangles. So there's actually a cool formula here for in terms of lateral area, because lateral area is equal to the perimeter of the base times the height. So this is a formula that you will have to know and be able to apply. So we'll write this out. Lateral area is equal to perimeter of the base, that's P, times the height of the prism. And that's H, right? P for perimeter of the base, H for height. So let's look at an example here of that before we get into total area. So we may have to practice drawing some 3D figures. For the most part, I will give you your images in a quiz or within your homework, but sometimes it's helpful to know how to draw these. So I'm going to draw a triangular prism, and how I'm going to do that is I'm going to draw this triangle here, and then I'm going to draw the same triangle, but I'm going to cheat a little bit, sorry. If I do the same triangle over here, so I just drew the same triangle, one on the left, one on the right, and then I'm going to connect their vertices here. So I've got this one, and then this one I'm going to give like a dash line in the back here, because let's say like you couldn't see that, but you need to know that it's kind of there, as well as, you know, maybe we could make part of these dash lines as well. There you go. So this is a triangular prism. Now, be careful with this, because your base for this triangular prism is actually the triangles here. So I know it's not the bottom. Everybody always wants to think that it's always the bottom of whatever your prism is. In this, it's actually like the sides, because it's tilted on its side. But remember, your bases have to be two congruent and parallel polygons. Here it's the triangles. I can't call it the rectangles because they're not parallel to each other, right? They're all intersecting with each other. So let's fill in some information here. I'm going to call this edge 4 inches. This one's going to be 8 inches. And then over here, I'll call this one 5 inches. And then 13 inches down at the bottom here. So if these are all the edges that I'm giving the lengths there, the first thing that we really want to do is figure out what is the perimeter of our base. Now my base being this triangle down here, or the triangle up at the top, our base is going to be all of these edges, or the perimeter of it, all these edges added up. Now if this is 5 over here, I can drag that over, whoop, and also call that the edge of this triangle is also 5. So my perimeter is going to be 4 plus 8 plus 5, which is 17 inches. So if I wanted to find out what's the lateral area of this triangular prism, my lateral area is perimeter of the base times the height. So my perimeter of the base was 17. My height here is 13. Remember that your height is the distance between your two bases. So my height was this 13 here. That's the distance between my two triangles. So my lateral area is going to be 221, and then this will be inches squared because we're talking about area. So that's lateral area. That is the area of all of your lateral faces of a prism. We also have something called total area, and total area is the area of every face of the prism, including the bases that you have for that prism. So the formula that we use for total area, and a lot of times you'll hear surface area used instead of total area. Those two phrases are interchangeable. So total area is equal to your lateral area. So you have to find your lateral area each time, plus 2 areas of your bases. So that's your formula. Total area equals lateral area plus 2 areas base. So let's write that out. Total area is equal to lateral area, that's LA, plus the area of both bases, which we represent with 2a subscript base. That's just saying 2 times area of each base. So let's apply this here. I'm going to draw a rectangular prism here. So let's do this. I'm going to draw a rectangle here. And then copy. I'm going to paste that over here. Oh, I don't want to do that. There we go. So I'm going to kind of offset it a little bit. And then I'm going to connect my vertices, my vertices. And I really only have to have 4 lines that are connecting the two, but this is like the easy cheater's way to making a rectangular prism. And then I'm going to add some dash lines inside so we can kind of see which ones are in front and which ones are kind of hidden behind. So here's our rectangular prism. I'm going to add some distances here. So 9 centimeters going up the side. It's 5 centimeters down at the bottom here. It's 12 centimeters down on the other side. Now, if you really want to start each problem by copying over the corresponding lengths, so you know that this one here is going up is 9. This is also 9 centimeters. This one in the back is 9 centimeters. That's fine. You could also transpose that to here's 5 centimeters. This one would also be 5 centimeters down here. This is 5 centimeters over here. And then you could do the same with the 12. 12, 12, and 12. I know a lot of students find it easy to write in all of their sides. Sometimes I think that's just a little bit more confusing, but it's all based on personal preference. So Perimeter of the base. Now for a rectangular prism, because it's a rectangle, your bases can actually kind of be whatever sides that you really want here. So I'm just going to call my base the bottom and the top of this actual figure. So like here's my base down here. We'll call that one base. And then this is going to be our second base up top here. So there's my two bases. I first want to figure out what is the perimeter of the base. So that's 5 plus 12 plus 5 plus 12. So the perimeter of the base is 34 centimeters. My area of the base, so area of the base, is length times width of the rectangle. So 5 times 12, which is 60 centimeters squared. So let's figure out lateral area first. Lateral area is perimeter of the base times the height. So lateral area is perimeter of the base is 34. The height was 9, the distance between our two bases. So my lateral area turns out to be 306 centimeters squared. Then let's do total area, which is LA plus 2 area of the base. So total area is LA, which is 306 plus 2 areas of the bases, so 2 times 60. So our total area is going to be 426 centimeters squared. So that is our total area of this whole shape. Essentially saying that if I wanted to pick up this shape and paint the entire thing, and I needed to know how much surface area am I gonna cover there, or how much paint am I gonna need to cover it all, I have to know all of the area of each face. So copy these notes into your notebook. The template for page 41 is provided. 42 you'll have to draw it in by hand. Make sure you hit that like and subscribe button. We'll spend a bunch of time doing practice problems for lateral area, total area, surface area, and then we'll eventually